going to talk about geometry with the focus on quadrilaterals. There are two major rules that a quadrilateral must follow is that it has to have four sides. So any four-sided figure where all the four angles are going to add up to 360 degrees. So if you add up all the interior angles, it's going to add up to 360 degrees. Now, there are specific rules that we're going to have to know about certain quadrilaterals this year, focusing on 5th grade material and 6th grade material and on, and I have made what we call a quadrilateral family tree. We're going to go from the very basic stuff all the way down to the very specific stuff. I'm going to talk about each. Now, the first one, we have a trapezoid. Trapezoid's kind of a thing that's all like of itself. Then we have a kite. Once again, it's something that has separate rules from everything else. And here's where we get into the nitty-gritty stuff, our parallelograms. Parallelograms have two opposite sides that are parallel, and then if you get into more detail, you have the rhombus, which is a parallelogram, and a rectangle, which is a parallelogram also. Now, rhombuses and rectangles are not the same. They are different. They're parallelograms, but they have distinct rules. And the last thing we're going to talk about, which actually has the most rules, even though that's probably what you're most familiar with, is a square. And a square is strange because it is both it follows the rules of a rhombus, parallelogram, and quadrilateral, and it follows the rule of a rectangle, parallelogram, and quadrilateral also. So let's get into a deep dive of what each of the things are, what are the rules, and what do they look like. So on this right side, there's a lot of review stuff, but we're only focusing over here. Now, we said the very first rule is a quadrilateral is any four-sided polygon that is closed in and has four angles. So here's an example, or here's my visual. It's going to be broken down into three sections. We have our names, we have the description, or another word we can call as rules, and then we have our visual for each. So quadrilateral just has to have four sides with angles that equal up 360. Now we're going to get into our parallelograms. A parallelogram has two sets of parallel lines, meaning that they will run forever and ever without touching. You have this set going this way. That's what those triangles represent. And then you have another set going this way. The next is, a lot of people forget this, is that you have two opposite equal side lengths, meaning that this length and this length is the exact same, and this length and this length is the exact same. And also, with those equal sides, you have equal angles, meaning if I was to take a protractor and measure this angle and this angle, it would be the same. And if I was to measure this angle and this angle, it would be the same. So parallelogram, even though it looks simple, has lots and lots of rules. The next thing is a rectangle. You can probably draw a rectangle without even thinking of it. It's going to look something like this. Mine's not going to be perfect. And what a rectangle is, it's a parallelogram, meaning it follows all the rules of a parallelogram. Parallelogram, I always mess that up. Except the distinct difference is that it has four right angles. So while the opposite angles are going to be the same, that's because all angles are going to be the same because they're all right angles. And they'll show you that with squares. So what are the parallelogram rules? Well, opposite sides are parallel. That's true. That's true. Opposite sides are equal. That's true. That's true. That's true. That's true. Opposite angles are equal. We talked about that. They're opposite and they're right angles. Now, what's a rhombus? A rhombus is a parallelogram, but what makes it different, so if I was to go through the parallelogram rules, opposite sides are parallel. Yep. Yep. Opposite sides are equal. Yes, yes. 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 Opposite angles are equal. Yes. Yes, yes. Yes, yes. But even though they opposite sides are equal, it's actually going to have 4 sides that are equal. So the opposite ones are equal, but really this side, I'll show you with the color, this side and this side and this side and this side are all the same length. Then we get into our square, which is strange because even though it's one of the most simple figures, it looks something like this. Oh, help if I drew it really good. So a square, even though it's the simplest, it actually has some of the most rules out of everything. It's a parallelogram. I didn't mess it up this time. With 4 congruent sides, every single side is going to be equal, and it's going to have 4 right angles. So right angle, right angle, right angle, right angle. And it's also true that you have 2 sets of parallel lines that will never ever touch. The last one is a trapezoid. What makes it weird is it's going to look like this. I'll do it in black. It's going to look something like this. And the only real rule that a trapezoid has to have, it is going to have one set or one pair of parallel lines. That's the only rule it has to have. So meaning that these are not parallel because eventually they would touch right about here. So that doesn't work. But these lines would go forever and ever without touching. Now, a regular trapezoid, like the one we just drew, also has some other characteristics that are the same, like this side and this side are the same length, this side and this side are the same length, but that does not have to be true of all trapezoids. Like if I was to draw this over here, well, that wasn't really a good one, but I guess I could draw it with a little bit short of a face on this side, like this, this, this. That is still a trapezoid because these 2 sides would run forever and ever without touching, yet these are different lengths and these are different lengths. So a regular trapezoid looks like what I drew in black, but the only real rule it has to have is it has to have one set of parallel lines, and the last one is a kite. Weird one because what a kite is going to have, it's going to look like this over here, obviously, and it looks like an actual kite. If I was to draw these lines in the middle, if I was to connect the opposite sides, what's going to happen is that you're going to have 2 sets of equal sides, this, 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 and if I was to draw that line, which I already drew in blue, I'll draw in pink so you see what I'm talking about. If I was to draw that and connect it, I have perpendicular lines, meaning when they connect, it will make 4 right angles. So those are my rules for quadrilaterals. Even though quadrilaterals seem fairly simple, just 4-sided figures, there's actually quite a bit to know about them, and this would be a great visual to screenshot so you can have it for whenever you need it. Thanks for watching. Make sure to like and follow and keep up with all my new content. Thanks, guys.